Imagine building a C++ program that can remember things, not just while it's running, but even after it's closed. That's where file handling comes in. In the real world, data persistence is everything. Whether it's saving user preferences, storing game progress, logging data, or managing large databases, your program needs to read and write data to files. Without this ability, everything your program does would vanish the moment it stops running. File handling in C++ gives your application a memory that lasts. It allows you to create, open, write, read, and modify files on your system, all using tools built into the standard library. In this video, we'll unlock this powerful feature step by step. We'll start by exploring the special tools C++ provides, like fstream, ifstream, and ofstream, and how they work behind the scenes. Then, we'll write real code that interacts with files just like professional software does. By the end of this lesson, you'll be able to build programs that talk to files, whether it's for saving data, loading settings, or analyzing logs. Ready to give your C++ programs a voice and memory of their own? Let's dive into file handling. Think about all the apps you use every day, from web browsers and games to note-taking tools and messaging apps. What do they all have in common? They remember things. Your browser remembers your history, your game remembers your progress, and your to-do list remembers your tasks, even after you shut them down. How? File handling. Without file handling, your programs are like goldfish, they forget everything the moment they stop running. That's not how real-world applications work. In real life, we need programs to store data permanently. A text editor needs to save your document. A banking app needs to store your balance and transactions. A game needs to save levels and scores. Even system logs, configuration files, and user preferences, they all rely on file handling to exist beyond a single session. That's why file handling matters. It transforms your programs from short-term thinkers into long-term problem solvers. So, if you want your C++ applications to behave like real software, ones that can save, load, and manage data, you need to master file handling. It's not just a feature. It's a necessity. To work with files in C++, we need something called file streams. Think of streams as pipelines that connect your program to a file, letting you either send data out or bring data in. There are three main types of file streams in C++, ofstream, output file stream. This is used when you want to write data to a file. Just like using cout, but instead of printing to the screen, you're sending data to a file. Use it when you want to create a file or overwrite its contents. Ifstream, input file stream. This is used to read data from a file. Similar to using cin, but instead of typing input, you're getting it from an existing file. Use it when you want to access file contents line by line or character by character. Fstream, file stream, input plus output. This one does both, it can read and write. If your program needs to read a file, make some changes, and save it, fstream is your best friend. Here's a quick analogy, ofstream is like writing a letter. Ifstream is like reading a book. Fstream is like editing a document with comments. And just like you need to open a file before reading or writing, you also need to close it once you're done, using .close. Otherwise, you might run into errors or corrupted data. Understanding these three file streams is the first step to mastering file handling in C++. Each one has a purpose, and together, they let you build powerful applications that can store and retrieve real-world data. To work with files in C++, we need to include a special library, and that's fstream. Just like how we include ifstream to use cin and cout, we include ifstream to handle files. Think of ifstream as your gateway to the file system. It gives you the tools to read from and write to files stored on your computer. Inside this library, there are three main classes: ifstream, short for input file stream, used for reading from files. Ofstream, short for output file stream, used for writing to files. fstream, a flexible one that can do both reading and writing. To use any of them, simply include the header at the top of your program like this, include ifstream. That one line unlocks the full power of file operations in C++. By the way, it's always a good habit to also include ifstream, because you'll often use cout to debug or confirm that file operation succeeded. With fstream, your C++ programs gain the ability to interact with the real world, saving and loading data from files just like real applications do. Now that we've included the library, let's move forward and learn how to create and open files in C++. Let's now move from theory to actual file creation. In C++, if you want to create a file or write to one, you use the ofstream class. That stands for output file stream, meaning data is going out from your program into a file. Think of it like writing a letter and placing it in an envelope. Once you seal it and drop it into the mailbox, it's out of your hands and saved for delivery. That's what ofstream does for your data. Here's how it works. First, you include the fstream library. Then, you declare an ofstream object, just like a variable, and associate it with a file name. If that file doesn't exist yet, it will be created. If it does exist, it will be overwritten by default. For example, include ifstream. Int main. std, ofstream myfile, data.txt, myfile hello, file, myfile.close, return 0. This program creates a file called data.txt, writes hello, file, into it, and then closes the file. That close function is important. It tells the system you're done writing, so it safely stores the data. Now let's break that down further. Ofstream myfile, data.txt, this line opens or creates a file named data.txt. It's now ready to receive content. Myfile hello, file, this writes a line of text into the file, just like how we use cout to print to the screen. Myfile.close, this closes the connection, ensuring everything you wrote is saved properly. One important tip, always close your files. If you don't, the data might not be saved completely, especially in large applications. So, with just a few lines of code, you've taken a big step. Your program is now capable of writing permanent data into real files on your system. And that's just the beginning. We're going to explore how to read files next. But first, try this out on your own and make sure your file is created exactly where you expect it to be. Now that we've learned how to write data to a file, let's flip the process. How do we read that data back into our program? That's where ifstream, input file stream, comes in. It's the C++ class designed specifically for reading data from files. Think of it like a scanner that takes text from a file and feeds it into your program line by line or word by word. Here's how it works. First, you create an ifstream object and open the file you want to read from. You can either pass the file name directly when you create the object, or call .open later. Once the file is open, you can use input operators, or functions like .getLine, or .get, to extract data, just like you would when reading from cin. But reading from a file requires attention. What if the file doesn't exist? What if it's empty? What if the data format isn't what you expect? That's why good file reading code always checks if the file opens successfully using .is_open, or simply by checking the stream's validity in an if statement. And once you're done reading, always remember to close the file using .close. This frees system resources and ensures nothing breaks if the file needs to be accessed again. File reading in C++ is a powerful tool. It allows your programs to load saved data, process logs, import settings, or even interact with external data sources. Whether you're building a contact list, reading a game save, or importing configuration settings, mastering ifstream opens the door to a world of possibilities. Let's imagine you're keeping a journal app. Each time you write a new entry, you don't want to erase the old ones, you want to add the new entry to the end of the file. That's where appending comes in. In C++, if you open a file using ofstream, it usually overwrites everything in that file. That means the previous data is lost unless you tell the program specifically, hey, don't delete what's there. Just add to it. We do that by using something called iOS app, short for append mode. Here's what it looks like: ofstream my file, log.txt, iOS app. This small change tells C++, open the file and write at the end of it, not the beginning. Now every time your program runs, it can add new lines of data without deleting the old ones. Perfect for things like logs, scoreboards, chat histories, error messages, or anything that grows over time. It's simple but powerful. One thing to keep in mind: if the file doesn't exist, append mode will still create it. So even if it's the first time writing, you're covered. In real-world software, append mode helps us track progress, build histories, and make sure nothing important gets accidentally erased. So whenever your program needs to keep adding to a file without wiping it clean, iOS app is your best friend. When working with files in C++, just opening or writing to them isn't enough. You need to make sure your file operations are safe, successful, and reliable. That's where file status checks come in. Imagine trying to read a book in the dark, you'd miss all the details. Similarly, if your program tries to read a file that wasn't opened properly, it can crash, corrupt data, or give you wrong results. That's why we always check: is the file really open? Is it still readable? Is it at the end? Let's start with .is_open. This method tells you whether the file stream was opened successfully. It's a simple test that prevents your program from moving forward with a failed file operation. If the file didn't open, you can show a friendly error message or take an alternative path, like creating a new file. Next, there's .eof, which stands for end of file. This is useful when reading files line by line or word by word. It tells you when the reading has reached the end, so you don't accidentally try to read past it and get junk data or errors. You also have .fail and .bad, two more tools to catch problems. .fail checks for general input-output failures, like trying to read a string into an integer. .bad is more serious. It means something went really wrong, like hardware issues or file corruption. These file status checks make your program smarter and more stable. They help you handle unexpected situations, like missing files or bad formats, without crashing. So remember, file handling is not just about writing code that works. It's about writing code that keeps working no matter what happens. And that starts by always checking your file stream status. We've read from files, we've written to them, and we've even checked if they're open or reached the end. But before we move on, there's one critical step left: closing the file properly. You might be thinking, is that really necessary? Doesn't the program close automatically when it ends? Yes, it does, but relying on that is risky and unprofessional. Here's why: when your program finishes working with a file, you should explicitly tell the system, hey, I'm done with this file. You can free up the resources now. That's exactly what the .close function does. Calling .close on your ifstream, ofstream, or fstream object ensures two important things: all data is flushed from memory to disk, nothing is left behind in a buffer. The system resources, like file handles, are released immediately. Why is this crucial? Because when you don't close your files, you might lose data if the buffer wasn't written. Your program might run into system limits on open files. On long-running applications or embedded systems, this can cause memory leaks or unexpected failures. So, here's the best practice: every time you open a file, always close it when you're done. Offstream file, data.txt, write something. File hello, world, now close it. File.close, it's a small step, but it makes your code cleaner, safer, and more reliable. And remember, when you're using file streams in C++, managing them responsibly is part of being a great developer. Closing your files properly is a habit worth building from day one. Let's bring everything together in a real coding demo. Imagine this scenario: you're building a simple contact saver. You want to allow the user to input a name and age, store them in a file, and then read them back later. Simple idea, right? But it involves several key steps. First, we need to create or open a file for writing using ofstream. Then, we'll ask the user to input their name and age, and we'll write that data into the file. After that, we'll open the same file using ifstream and read the contents back to display them. Finally, we'll close the files properly. Let's write the full code to see it in action step by step. Here's how we do it in C++. Include ifstream. Include defstream. Include string. Using namespace std, int main. String name, int age, ask user for input. Cout enter your name, getLine, cin, name, cout enter your age, cin age. Write to a file. Ofstream out file, contact.txt / if, outfile.is_open. Outfile name gendel, outfile age gendel, outfile.close, close the file after writing. Cout data written to contact.txt successfully. Endl, else. Cout failed to open file for writing. Endl. Read from the file. Ifstream in file, contact.txt, if, infile.is_open. String read name, int read age, getLine, infile, read name, infile read age, infile.close, close the file after reading. Display read data. Cout data from file, endl, cout name, read name gendl, cout age, read age gendl, else. Cout failed to open file for reading. Endl. Return 0. Let's break this down. We included the fstream library so we can use ofstream and ifstream. We asked the user for their name and age using cin and getLine. We wrote that info into contact.txt using ofstream. Then, we opened the same file using ifstream to read the contents. We displayed the name and age back to the user. And we made sure to close both files after use. This small program demonstrates real-world file handling, reading, writing, checking status, and closing. A perfect wrap-up of everything we've learned so far. When working with file handling in C++, many beginners, and even experienced developers, fall into a few common traps. Let's go over these mistakes so you can avoid them confidently. Mistake 1, forgetting to include the fstream library. A simple but frequent issue. Without include ifstream, your compiler will throw errors when using file streams like ifstream or ofstream. Always start with including the right header. Mistake 2, not checking if the file opened successfully. Opening a file doesn't guarantee it exists or is ready to use. If you try to read from a file that failed to open, your program might behave unpredictably or silently fail. Solution: always use .is_open to verify the file status before using it. Ifstream file, data.txt, if, file.is_open. Cout failed to open the file. Endl. Mistake 3, using the wrong file mode. When opening a file, be clear about whether you're writing, reading, or appending. For example, using ofstream without the iOS app flag will overwrite the file contents every time. Be very careful, one wrong flag can erase your data. Mistake 4, reading past end of file. Many new developers keep reading the file in a loop without checking .eof. That leads to invalid data or infinite loops. Tip: use a safe read loop like string line, while, getLine, file, line. Cout line gendl. Mistake 5, not closing the file. Forgetting to close a file stream can lead to data loss or file corruption, especially when writing. Although files are often closed automatically when the stream object goes out of scope, it's a best practice to close them manually using .close. Mistake 6, mixing input and output without flushing. When using fstream for both reading and writing, you must flush the output before reading. Otherwise, your program might not behave as expected. Flush or close the file before switching operations. Mistake 7, using wrong paths. Using absolute paths like C, users use desktop file.txt may work on your PC, but not on someone else's. Prefer relative paths, or ensure your app checks the environment before file access. Mistake 8, assuming file format. Don't assume the file is always in the format you expect. For example, reading integers from a text file that has strings will fail. This can crash your program or give incorrect results. Use input validation whenever possible. Bonus mistake, file locks and permissions. Trying to access a file that's locked or permission restricted can fail silently. Always check your system permissions, especially on Linux or Mac OS where file permissions are strict. Summary: file handling is powerful, but it's easy to misuse. By avoiding these common pitfalls, your code becomes more robust, secure, and portable. Remember, treat files with care, just like you would with important real-world documents. Ready for a mini quiz to test what you've learned? Let's go. Alright, time to test how much you've learned. Let's jump into our mini quiz and challenge your understanding of file handling in C++. Question 1. Which header file must you include to use file streams like ifstream and ofstream? A. ifstream. B. ifstream. C. phileo. D. stream.h. Take a second to think. Correct answer, B. ifstream. We used ifstream to gain access to file input-output classes in C++. Question 2. What does the is_open function do? A. Opens a new file. B. Checks if the file is ready for writing. C. Returns true if the file stream is open. D. Closes the file stream. Think carefully. Correct answer, C. Returns true if the file stream is open. It's a helpful method to ensure a file was successfully opened before performing any operations. Question 3. Which file stream class is used to write data into a file? A. ifstream. B. fstream. C. ofstream. D. filewriter. Got it? Correct answer, C. ofstream. The ofstream class is specifically designed for writing data to files. Question 4. What will happen if you try to open a non-existing file using ifstream? A. A new file will be created. B. The program crashes. C. The file opens in append mode. D. The stream fails to open and is_open, returns false. Correct answer, D. When reading with ifstream, if the file doesn't exist, the stream fails to open. Final question, which of these is not a common mistake in file handling? A. Not checking if the file opens successfully. B. Forgetting to close the file. C. Using ifstream for writing data. D. Declaring a file stream globally. Correct answer, D. While not ideal in design, declaring a file stream globally is technically allowed. The other options are real mistakes. Well done. Whether you got them all right or missed a few, this quiz helps reinforce what we've covered. Next up, the final challenge, where we combine everything into one solid file handling project. Alright, it's time to put everything we've learned to the test. Welcome to your final challenge for mastering file handling in C++. We're going to build a realistic mini-project that involves writing, reading, appending, and handling file errors, just like you do in real-world applications. Here's the challenge: you'll create a simple student record system. The program should allow the user to add new student records, view all student records, append more students, and safely exit while ensuring files are closed properly. This may sound like a lot, but don't worry, you already know everything you need to build it. The system will use a file named students.txt. Each student will have a record in the following format: name, age, grade \n. For example, Alice 19A to Bob 20B+. It's simple and human-readable, perfect for this beginner project. The program will show a menu like this: 1. Add new student. 2. View all students. 3. Append more students. 4. Exit. The user will select an option, and your program will handle the file operations accordingly. For option 1, create a file or overwrite if it exists. Option 2, read and display contents using ifstream. Option 3, open in append mode using ofstream. Option 4, close any file and exit gracefully. To complete this challenge, you'll use everything we've covered, include ifstream to access file stream tools, ofstream to write or append, ifstream to read, is_open to check file status, proper closing with .close, loops and conditionals for the menu. Optional, use getLine for better input handling. Be careful of a few things, always check if the file opens successfully. Watch out for mixing cin and getLine. Don't forget to flush or close files before exit. Avoid infinite loops, make sure exit works properly. This project will reinforce your understanding of file streams and show you how to build something useful with C++. Once you complete it, you'll feel more confident working with files, whether for logging, data storage, or configuration systems. Try to complete it on your own first. Then, in the next video, we'll walk through the full working solution together. Take your time, write clean code, and don't be afraid to break things. That's how we learn. Good luck, coder, you've got this. Well done for making it all the way through this deep dive into file handling in C++. In this video, we explored how to read from and write to files using streams like ofstream and ifstream. You learned how to include the fstream library, create and write to files, read data line by line, and even append data without overwriting. We also covered how to check the status of your files with methods like .is_open, and .eof, and most importantly, how to close your files properly to avoid errors or data loss. Through live examples, we tackled real problems, like storing student data, and discussed some of the most common mistakes that can trip you up when working with files in C++. And we wrapped it all up with a mini quiz and a final challenge to test your skills and help you solidify your learning. If you've reached this point, take a moment to appreciate how far you've come. You're now equipped with one of the most powerful tools in C++ for building data-driven applications. Don't forget to review the examples and try building your own mini projects using file input and output. That's how true learning sticks. As always, thanks for watching, and happy coding.